What's up, friends? Today we are here with another part in the VESC wheel build series, and in this video we're going to be assembling the controller box. We've got a whole bunch of parts here that look like not much, but all of this put together is what's going to make the thing actually go. We have our little Fokker, we have the VOW printed box that I printed myself, we have a heatsink, we've got some little foam pads for waterproofing, and then in the background over here we've got the bumpers and stuff like that. The rest of the stuff here is just for reference. We built the battery in a previous video, and in the next video we're going to be installing everything onto the rails, and that final video, or probably second to last video, will be bringing everything together. But right now we're putting together a controller box, so let's get right into it. Alright, to put this together, there's actually going to be a good number of things that we need. First off, you need your controller, whether it be a little Fokker, a U-box, a Thor, VESC, or what have you. Second, you're going to need your enclosure heatsink, or if you're just using a printed enclosure, you'll need your base plate. Third, for our install, we have these nice pre-cut pads that Mario provided me. Those will go with this VOW enclosure. We also have our base plate for the bottom of the enclosure, and then our heatsink topper for the top of the enclosure. The base of the enclosure is here, or I guess the frame you could call it. On here we have all of our spots for our different connectors that we need to put on. We have some cable glands that need to get installed, switchcraft connector, charge port, power button, etc. This is printed out of PAHTCF, which is a Bamboo Lab filament that is extremely strong. It's carbon fiber nylon, and this thing should hold up just fine. Along with this, there's actually a good bit of screws that we're going to need. Now, I'm going to put some reference from the VOW website on screen most likely, but let's just lay this out to show you what needs to happen. You have your base plate here. This needs to get screwed onto the bottom of the enclosure. This base plate is printed out of polycarbonate. This installs with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 M3 countersunk screws. They recommend 10mm ones. I need to check my stock and see how many countersunk 10mm ones I have, but it looks like I can go deeper if I need to. However, we also need to install a bunch of heat set inserts, which I actually have all of those already, but we need to install those, I think I said 13 inserts here. We need to install M5 heat set inserts into these outside parts. These will screw onto the rails over here. And then the base plate will screw on like that with the little foam spacer slash gasket. So now you have that. On the top side of the enclosure, you have a lot more inserts that need to be installed. So you need to install, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 more M3 inserts. And then the heatsink will come down with the little Fokker attached to it. And then on top of that, you'll have the airflow plate, and you'll have 16 M3 countersunk bolts that go through all of this and screw it into the frame. Hopefully that all makes sense, but what I'm going to do right now is go grab my inserts and my insert install tool, and then we'll go ahead and get rolling with them. All right, well, I just checked the, I don't know if it's VOW or VOW, but I checked their website, and it actually seems like I'm actually using an outdated version of this case already. So yeah, but it's printed already and I'm not going to change it now. So if you have the new and greatest and latest and greatest one with the, it looks like a round TPU gasket rather than the foam ones that I have, Your inserts may be slightly different than mine, but for mine, oh man, it's hard to install it into nylon. I need to turn the temperature up on my thing. Your inserts may or may not be the same as mine, but same concept applies. If you don't have an install tool like this one, you can buy an insert installer for your soldering iron, or you can literally just brute force it with the soldering iron tip, but I don't really recommend that. The insert tools are pretty cheap for most soldering irons, and they work quite well. Buying a whole tool like this is not necessary, but since I sell enclosures with these inserts already, this is very useful for me when I'm assembling my enclosures that have like 40 inserts on them, because it makes it much easier. And it's coming in handy here. And that's also the reason why I have like 1,000 of these M3 inserts. So we're just gonna go ahead and install the rest of these inserts on the top, and then we'll switch over to the bottom. Alrighty, we got all of the M3 inserts pressed in, and man, that took quite a bit of effort. This stuff is pretty tough. Now, we have what I believe to be 4 M5 inserts that we need to put into these 4 holes right here. I need to double check how this assembles onto the rails, because I want to make sure I put it in the right way. I think they have to go in this direction, because this side looks like it has a countersunk head space. So we're gonna pull out the rails and see how they mount. All right, I've never even attempted to figure out how these go in, so we're gonna figure this out together. I think, so the bolt pattern is different on the front and the back. This side looks like the one that would fit here, because it also has the charge port hole. So I'm guessing, think about it this way, it has to be like this. So then it would fit in there. There you go. So now these 2 holes line up perfectly with the rails, and the bumper fits on underneath that. It screws on there and there. Okay, so wait, does it? All right, after some tinkering around, I figured out how it's supposed to go. And I was correct that the M5 inserts are supposed to be in through the bottom. So this, with the metal heatsink on it, slots in and it bottoms out on a little bump stop. And then the screws go through into those inserts in the top. So we're gonna put in those 4 M5 inserts now, and then we'll move on. All right, so now we've got all the inserts in, I'm starting to assemble it just a little bit. And right now I'm just putting the base plate on to see how it's all going to stack up. And then before it gets finally assembled, I'll take it off again so I can put the foam gasket on. And honestly, really would like this to be pretty watertight, so I might do a bead of silicone on the inside bottom of this too, just to be safe, but we'll see. If I think it's not looking like it's going to be very water resistant, I'll do that, but if I think it looks fine, then maybe I'll just leave it. There's a good number of screws on here, but this foam gasket is, I mean, it's closed cell foam, but at the same time, I don't know. I feel like silicone's better, so. The only downside is that makes it less openable or repairable, I suppose you could say. So inside of here is going to be the controller. However, the controller is mounted to the lid, which goes in like this. So basically what we're looking at here is having to assemble the box with the lid on, but then you also kind of want to take the lid off so you can put stuff here and mount in the LED strip, I think. I do have the LED strips now. I got my Arduinos, so I can do the light setup and close up the battery box, and then also do the light setup on the front here. And the other thing that'll be in here, the other two things that'll be in here, is one, this buck converter, and then two, the Arduino that controls the lights. So I'm probably going to do the light video at the same time as this one, and I'm basically just going to be following Mario's guide on this, but I figured I would do it on video to show you guys how I got it done, and if there's any hard bits, I'll explain them. So let's see, what should we do next? I think I'm going to find my thermal pad, and we can get this. I believe it goes this way. I'll have to double check, but I'm gonna get my thermal pad, put it down on here, and mount up the ESC, get some screws on it, and then I think that part will be done, and it'll just be on there, so when we close the lid it'll all fit in the right spot, and we can kind of see how much space we have left over for the light circuitry. Alright, so we got our thermal pad here, and it's a little bit weird to figure out how much to put on here, but I'm just gonna sort of cut it approximately to size. The main point here is that we're providing an insulating layer between the MOSFETs and the heatsink. You don't want them to short out, so that's what we're doing. Just gonna draw a little line, slice it off. Should be fairly easy to poke holes through this, I believe, but I think what I'll do is I'll stick it on the Fokker first. Stick it on here, like that, and then we can poke holes through with something. Line it up with the screws on here. We need to make sure we get this in the right direction, I believe. With the connectors facing this way, it's this way. Yeah. There we go. Nice. There we go, we've got our insulating and thermal conductivity layer. And now what we need to do, well, first we'll double check that I put it on the right way, which I'm pretty sure I did. Yeah, we're good. Now we need to get some plastic washers to put on top of these screw threads, and some regular washers, and some, I believe these are M3 nuts. So grab those, and then we can attach the Fokker onto the heatsink somewhat permanently. I designed some M3 plastic washers real quick and printed them in about 8 minutes. So now we just need to put them on and put some nuts on here, and it will be tightened down and good to go. And then we can move on to assembling the box. All right, well, I got these screwed on. I double nutted them, tightened down the double nuts, and man, that was really annoying. I don't have a nut driver for these, so I had to manually twist them on with needle nose pliers. So that was special. But anyway, that's on there now. So I think we're going to go ahead and stick the foam on so that we can sort of semi-permanently install this. Now to put this down without getting it stuck in the wrong spot. And there we go. We've got a gasket. Now I think I can just go ahead and screw the walls on and be able to complete all this. Let me check if I can fit my USB-C cable in there before I screw this down. All right, I checked and it does fit. So we're all good to screw this down. So we'll go ahead and flip this over and get some screws in here. Of course, the phase wire goes right in the way. Now we're going to be using M3 by 10 and actually M3 by 12 here. And we need to install this on top as well. So just go around slowly and finger tighten them in until we've got it all lined up, and then we'll tighten it all down. All right, we're continuing the assembly of the front enclosure, and I decided that the next step I want to do is assemble the charge port. So originally this VOW box design calls for a GX16 connector, and I do have those and I've used those in the past. I actually have it here on the table. I'll show you what it looks like, but I don't like them that much anymore. This is what it looks like. It has two exposed pins. It can be shorted pretty easily with a metal outside, but I've liked using the SF12 connector by WAPU lately. I'll compare them here. So this is the SF12. Much higher quality, more sturdy materials in my opinion, and it also has a locking click on interface and then release, and they just feel really nice. So I will be using this one. I tried it already with the rail to see if the cap would fit, and it does. The little rubber bit that attaches here gets kind of squished, but it works. And I mean, worst comes to worst, I just rip it off and make a TPU cap, but it fits perfectly in the hole. So I'm going to be using this one. So we're going to wire this up real quick to the charge port fuse, and also a MR30, which will hook up directly to the cables that come from the multi-strand conductor from the back of the board. People go back and forth a bit about whether or not it's worth using a fuse on your charge port, at least in Eastgate, and I feel like it's pretty much just free security. As long as you use a properly rated fuse, you're protecting your BMS, especially if it doesn't have good short protection. The JBD BMSs do have good short protection, so it's kind of redundant in that case, but I don't really know how the Z BMS is. So we're going to be using this mini fuse holder and soldering that up here. And the other side will go to the negative on the MR30, which will go to the back of the board. For all of my charge ports, I always wire the number 1 as the positive and number 2 as negative, just to keep things consistent. I don't actually have an 18S charger right now that has this connector on it, but I just like to stay consistent. So positive with the fuse on 1. All right, finished up the charge port soldering. So now we have SF12 with a fuse and an MR30 on the other end with the positive on the hanging end. Now, also I messed up here and I soldered the fuse on before I put the nut on, so I had to desolder it and then re-put it on so I could put the nut on here. Now, this whole thing can get fed into the side of the main enclosure. Also, I checked the fuse fitting here before. And then it can get screwed on using a couple M3 countersunk bolts. So we'll do that now. And I think before I do final assembly, I'm going to seal silicone under here, or seal it with silicone, so that no water can get in through the joint. All right, our charge port is now connected. On the other side, we have the power button. So this power button is quite large. It's a 19 millimeter power button. However, on this standoff, there's not actually enough space to put the nut. So that's an interesting design decision there. So it just kind of sits in there. So what I'm thinking is that I'm going to need to just fill the back side with hot glue or silicone, or stick some hot glue in here and shove it in, because otherwise it's not going to be very secure. So I think we'll go ahead and do that now so we can get that part of it done. While we're adding things to the enclosure, there are a couple other things we need to put on. We need to put the M20 or PG 13.5 gland here. We need to put the switchcraft connector here, and we need to put another gland here for the Intrabox cable connection. So I'm going to grab a couple of those glands and the connector, and then we'll put them on. All right, so first we'll do the switchcraft connector, and this is for the foot pad. I believe the foot pad one is just the 3-pin, because the other one is meant to be used for the motor. For me, my motor already has a, a JST on it, because mine is a first gen Superflux. So this will plug directly into the VESC instead of going through the connector, which is fine. And then for the foot pad, we need this one. This switchcraft connector is one of the super expensive ones. I got this with a Maker's PV bundle that I had a while ago, and this will connect directly to the stock connector on the OneWheel factory foot pad. So we'll go ahead and stick this on the enclosure now. And then this will plug into the VESC somewhere. I'm not exactly sure, I need to look it up. All right, we've got our PG 13.5 glands here. And these are ones that I just happen to have laying around as well, because I use them on the ESC enclosures that I make. The only thing is, I think with these plastic ones, the nut is a little bigger than the metal one, and it's not going to fit. So that's quite unfortunate. Now, I do have 2 metal ones by chance from a Maker's PEV kit. So I have 2 options. I can either trim this nut a lot to make it fit, or I can chop them off that kit. And I think I'm going to chop them off that kit, because no one wants to buy it anyway, and cutting these nuts down sounds really annoying. The other option is I just like silicone this straight in, just right in there, but that's also annoying. So we're just gonna chop them off and see if they fit properly. Well, it turns out the metal one doesn't have enough thread to fit in there. So that was kind of a waste. But the plastic one does. So now I'm trying to figure out if I can shove this nut into this printed joggle. And if I can't, then I will have to trim the nut. Otherwise, we're just stuck siliconing the actual connector in. But it seems like I might be able to shove it in if I try hard enough. One thing to note while we're looking at it from this angle, the foot pad connector, this 3-pin one, actually connects to a dedicated ADC port here. So, little Fokker being made for these and people using it for these, that port comes really nicely in handy. Unfortunately, these cables are super long, but they'll just have to get stowed somewhere in here. And then the switch plugs into the switch port on the little Fokker, and I'm sure I'll put the schematic for the little Fokker up at some point for reference. Well, I had to go absolutely caveman on this plastic nut, chopping off corners to get it to fit in there, but it ended up threading in and it is locked securely in place. So now we'll want to backfill the outside of this with some silicone to make sure that there's no leaks. But it works, it's just annoying. So now I have to do that again on this side. All right, so I'm working on closing the battery box up, but I wanted to make sure I got the main battery leads and the charging leads connected to their connectors before I plug in the battery, because that will avoid the ability of them to short. So we're connecting the XT60 right now to the main battery discharge leads, and we're also going to tee in a little MR30 off of that to plug into the buck converter, and that will give us power to our lights. So it should be pretty quick and simple. And then we will connect the MR30 for the charge port, and that should be good for now. So we got our charge, or sorry, not our charge. We got our buck converter discharge port, and we got our discharge for the VESC, and now we're going to do the charge port, which will connect to this connector and go to the charge port out of the board. So now we're going to do this guy. All right, so we just got to stuff all these cables in here carefully. And then we can close it up. I don't think this should be too difficult. Okay, it might be a little bit tighter than I thought. Maybe we'll just flip it over and take the bottom off. That way we're not squishing anything that shouldn't be squished. Right, we have a better view now, so we can more carefully pack stuff in here. And I mean pack because this looks like it's going to be quite tight. And we're not going to permanently, I say permanently, it will always be openable, but we're not going to permanently close this until we're able to get the motor plugged in through this other cable gland over here. So right now it's really just about organizing the cables sort of out of the way so that it's able to seat properly, and we can stick some screws in on the bottom. I think that was enough. So now we can carefully flip this over and put some screws in so that this stays in place. Of course, we need this, and then we need all of our M3 by 12s flathead Allen key bolts. I'm gonna put them all in a little bit loosely, but enough to hold it down. Alrighty, it's time to connect some stuff up. I did actually get my epoxy, so I can finish the lighting video, but for now we're just going to connect stuff, and we're going to start in the back by connecting a couple things. And we're not going to connect the power yet, because what I'm going to do is I'm going to pre-charge the little Fokker with my power supply, and then unplug it, and then I'll plug it into the battery so there's less of a spark when we plug it in. Since there's no anti-spark circuit and no XT90S or anything like that in this battery, I would rather keep the spark to a minimum. It won't really hurt it, but if we can help it, we might as well. So first thing we're going to connect is the charge port. So we see plus minus here are the red and black. Plus minus on the other side are the red and black, and those are plugged into the charge port. So we'll go ahead and stick this in there and loosen this so I can pull it in a little. There we go. There's one. Next we've got the lighting, which is right here. You can plug that in. Positive, negative, and signal. And then we've got the battery. This is not plugged in. Yeah, so we'll plug this in here. And that is all the connectors in the back. So now we've got all that, and we can figure out where to put this lighting cable. And there we go. That's pretty much the rear enclosure done, ready to be sealed. We'll see how tight this is. I bet it's going to be pressing on the lid a good bit, but hopefully we can get that tightened down without any issues. So all that is connected. Now we can go up to the front and hook stuff up, since the cables are all the right length now. All right, so in interest of getting this all plugged in, let's go ahead and plug in a couple of these accessories. So I'm going to try to pre-charge the little Fokker like I mentioned, so I can double check all the lights before we close it up permanently. So let's go ahead and plug in the switch. The little Fokker switch goes into this port right here. So we'll go ahead and plug that in. Bam. Put that on the bottom. Next, we need to plug in the foot pad, which is this guy. And that's going to go into the ADC port. ADC port is up here. We can always recoil these wires and organize them later, but I just want to make sure that this is functional. Next, we'll go ahead and plug in the lights. So we got blue for front now because I switched them, if you recall, and the UART port. So we'll plug in UART into the appropriate spot, which is over in the corner, one pin over. Got that one. That goes to Arduino. All that's fine. And then we have our front light lead right here. This will get plugged into blue. Got that one. And then the rear one is actually on the harness that goes to the rear of the board over here. So we'll plug that in. Now we have one more cable to connect, which is the T off of the discharge. which is going to be right here. This is for the buck converter to be powered. So we'll go ahead and plug that in. I believe that should be everything except for the main discharge cable, which is currently plugged into the power supply. So now I'm going to power up the little Fokker with power supply and then hopefully plug it quickly into the XT60 from the battery without too much of a spark. Alrighty, my plan worked perfectly. There was almost no spark when I plugged in the XT60 here, and now we get to do the job of organizing everything, but that should be pretty easy. So now when we turn on the power button, lights come on, and you can't see it, but the tail light came on as well. So that to me means I can button everything down and we'll be good to go. So that is super exciting. All right, the rear enclosure is now sealed. All of the bolts are in. The only thing left to do is stick the Gore-Tex breather vent thingy on it, but you can see here, tail light on, fade down to battery percentage. Pretty sweet. All right, now that the rear enclosure is done, we can focus on the front, and I want to get some silicone on these two gaskets. I think that this switchcraft connector is fine. I don't think that any water can get in through there, but we might backfill on the rear side with some silicone just in case, or maybe I'll loosen it and put some silicone in the little crevice that it sits in, and then tighten it back down again. But in any case, I need it for these. But before that, I'm going to affix the buck converter into the bottom, and we're just going to put a little piece of fish paper on the terminals to make sure that it doesn't short out on accident. And then we can stick double-sided tape onto this and stick it down onto the heatsink. Not that it's going to be putting off heat, but that's just a convenient spot to put it. And that should be good. Now we have a lot of cables in here. I'm not really sure exactly how much cable management I'm going to do. I'll definitely do a little bit. But the main thing I need to do still is connect the motor, but can't really connect that until this is on the frame and I can stick the motor cable through here. So first, let's get that silicone done on the two glands. I really would like to put some on the button and the charge port as well, so I think we'll do that at the same time. Just unscrew these 4 screws, put a little bit on the surface between this printed part and one behind it, and then that will sort of affix it there more water resistant, in a more water resistant way. Alrighty, so now that the lights install is done, this front box is basically fully assembled. Now, there are a couple things to tie up in here. One, the motor is not hooked up, but we're going to save that for the setup video. Inside here, there's a couple cables that need to get organized better, but everything works and is ready to go. So I think I'm probably going to end this video here, and then in the next video we'll do the setup where we screw this onto the rails, we hook up the motor, and then I might split the VESC setup into a separate video. I'm not really sure yet, I need to watch some videos from Surf.0 and see how involved it is. But in any case, the assembly of this box is pretty much complete. I know this video is going to be super long, but hopefully you guys found it entertaining and useful to see what all goes into building something of this complexity and size fully DIY. Now, this would have been much easier if I just bought a float box, which is a metal, sheet metal version of this that's like all put together, and all you have to do is screw on the connectors. But I chose to print this. It ended up being a lot cheaper, and it should work quite well. I really like how this lights install came out on here, and I think that this will hopefully last for a good long while. So thank you guys so much for watching, and stay tuned for more videos in the VESC build series. The next video will be a lot more satisfying than this one because we will have an actually assembled board. So stay safe, keep on riding, and peace out.